Welcome to the Advances in Research and Innovation stream of SNOMED CT Expo 2022. My name is Peter Groves-Williams and I'm a technical specialist at SNOMED International. I will be moderating today's session. All questions will be answered at the conclusion of the presentation. Online attendees, please use the Q&A box to type your questions to the presenter. On-site attendees, please use the microphone provided. I'm now pleased to introduce Mark Czotter from B2I Healthcare, who will be presenting Semantic Similarity in SNOMED CT, Boosting Terminology Services with Transfer Learning. Mark, please proceed.
Yeah, welcome everyone. My name is Mark Czotter and I am from B2I Healthcare, Hungary. Let's introduce myself and my company a bit before we dive deep into the AI space. We've been involved with terminology tooling development in the last 10+ years. We've developed quite a few products related to terminology authoring and distribution. We've worked with NHS Digital and various healthcare organizations to deliver their SNOMED CT extensions, maintain their content, and maintain their life cycle, I would say. And let's talk about AI. In order to understand the AI, I think the question we have to ask is, what is similarity and what does that mean in SNOMED CT? From the Wikipedia definition, we can see that similarity is quality or state of having something in common. Let's bring a simple example from the geometry space. Or when we were kids, we learned that there are shapes. Shapes can be circles, rectangles, triangles, and basically any kind of shape. And as you were a kid, you already learned to perceive the similarity between the various shapes. In SNOMED CT, however, you have concepts, you have descriptions and various other things that can represent concepts, but how can we bring and represent similarity in SNOMED CT? Sticking with the geometry example, we can draw lines to represent similarities and combine the two words together. And for example, findings can be circles, procedures can be triangles, and medicinal products can be rectangles. Each of the color and the shapes and the form of the shapes, the characteristics can represent various SNOMED CT things like bacteria, concepts or concepts related to bacteria can be the green ellipses, and eye-related procedures can be the yellow triangles. SNOMED CT is huge. SNOMED CT has a bunch of data baked into it. 30 description extensions have been developed in the last 10+ years. There are millions of concepts and descriptions produced by authors, each and maintained over the last 10 years. And there are various functionalities and use cases where you can actually query those. You can query them in a way where, for example, searching for heart failure returns concepts that have descriptions that has the word either heart or failure, or you can use the expression constraint language to have some sort of semantic search or structurally semantic search in SNOMED CT. But these are not always produce the correct results, especially when it comes to keyword search. In some cases, you just don't have the capability of returning something that has the same meaning. The accuracy and relevance in our tooling and how we produce those results are quite relevant for the clinicians in the hospitals or the GPs. And while lexical searches rely on their descriptions and how they are entered when they are authored, entering more word fragments can reduce the noise of the search results, but can introduce other problems like you don't get back the things you'd like to see. In ECL, in order to produce results, you have to understand the concept model. You have to understand how it was developed by SNOMED International, how it is going to be maintained over the years. And there are various problems like historical associations should be included and stuff like that. At NHS Digital, we have seen that over the last 10 years, the clinicians and the GPs entered miscoded diagnosis codes in their EHR data. Things like they picked an organism instead of the disorder caused by the organism, or they picked the pregnant woman or pregnancy observable entity instead of the actual finding of pregnancy. And there are other problems in ontology mapping space, ontology matching or alignment, where you'd like to actually get correctly auto-mapped results in a concept map. At NHS Digital, we have seen like this example. This is very great because it just shows one of the problems, like 100,000 concepts are entered each year that has just the concept of soft tissue injury. There is no place where that injury happened and how severe it was and things like those. Same with imaging. The concepts are just the image concept, imaging concept. It's, you don't know what image were taken and at where in the body and things like that. One of the clinicians have at NHS tried to find a concept related to hematoma in the muscle structure. And it tried to search it by using simple lexical searches. And by default, he would like to see 4 relevant hits. But in order to produce those hits, you have to produce a, well, not that complicated, but an ECL expression to have all of those 4 relevant concepts in a single search result. You basically, at this stage in SNOMED CT, you can't return just using lexical searches. It is impossible because the descriptions were entered in SNOMED CT in a way, for example, inter and intramuscular are not, you are unable to, you will see in a moment what I mean by that. In order to improve these problems and eventually fix these, we have to introduce some new ways of searching SNOMED CT because lexical searches are just not good enough. And we all living in a modern age, and AI is just becoming more and more relevant and basically is everywhere because facial recognition software and voice recognition software. But for text, it was really hard up until this point. There are models out there where which you can use, which you can leverage and include in your SNOMED CT tooling. I'd like to introduce you a new kind of search. In the AI space, they call it vector search. With vectors, you represent your queries as vectors and your documents, SNOMED CT concepts or descriptions as vectors, and you search among those. You search those by measuring the distance between the query vector and the results. The more smallest the distance between the two, the more accurate the result is. You can use SNOMED CT, fully specified names, synonyms, the direct parent information, transitive closures, relationship types, the definitions, and so on in your vectors. You can produce vectors that are actually have a meaning transferred from SNOMED CT into a mathematical representation. How do we generate vectors? We need an embedding model in the AI space. You have objects on the left, you put those objects into the model, and it produces very long series of numbers. These numbers are called vectors, and you can measure the distance using cosine similarity and other various techniques between those vectors. There are hundreds and thousands of models out there. Researchers are producing these each day, and just it's so hard to find the right one. You need something that actually works. You have to put large amounts of money and effort into it to find the correct one. One thing I'd like to mention is just we are transferring knowledge from basically other spaces in our from humanity into the SNOMED CT space, we are transferring actual knowledge, like knowing that which words are relevant to each other and which doesn't have any relevance between the two, between each other. So we are transferring actual knowledge from other spaces to the SNOMED CT space when we are using these pre-trained, fine-tuned models. Let's go back to the example we had in the problems section, where the clinician was trying to find hematoma muscular. With AI, we can solve that. We know that hematoma and muscular have something, there's a meaning behind those words. And when we see, and for example, you see in this screenshot, you see that the results that came back from this keyword search using the vectors behind, you will get back all of those 4 concepts, and not just those concepts, but relevant concepts to hematoma and muscular. You can do this in various keyword techniques. You can improve your keyword techniques in a way that produce these results, but it requires a lot of effort. With vector search, it's more easy. The 4 examples are in an actual hierarchy in SNOMED CT, and if you browse those and try to find them with keyword search, you will be unable to do so. The other area is ontology matching, or mapping between 2 different ontologies. We've measured a couple of already produced and well-defined maps, like HPO to SNOMED CT, Loing to SNOMED CT, FMA to SNOMED CT from the ontology alignment track, and these like these. And we've seen that in general, you can improve your search accuracy and relevancy by 25 or even 20%, 15 and 25, something like that. It's 20%. You can see the numbers, like in the first row, we have a keyword search engine, Elasticsearch. It produces like 50 to up to the 80s in terms of Orphanet, for example. So it's quite okay, but if you go down, you see that with AI, we can do much better. When we use the fine-tuned algorithm, we can even reach the 95% of accuracy between when you map those ontologies. For certain ontologies, it's 75 or even 80. It's much, much, much better. The other area we have seen in the last years is authors need some kind of tool that can suggest reference at members. SNOMED CT is huge, but with the frequent releases coming in, they produce so much content, yet you are unable to keep up with the data. And you have a bunch of ref sets you manage, and you need some kind of tool that can help find the relevant concepts that should go into your reference set members or reference sets. And it's actually heavily context dependent, because ref sets are just a context of concepts. You put some context in it. And we've seen that while keyword search or some kind of search that can return suggestions to reference sets can help, in certain cases it's by 30%, but in certain cases it doesn't produce. You are just unable to produce a relevant suggestion to the reference set. It's like 0 or something like 0% of the measurement. For example, the sexual health issues reference set was quite funny, because it produced almost 60% of the existing reference set. The AI was able to construct the reference set from a small portion of that reference set and reintroduce the concepts that have been removed from that reference set. And it was just amazing to see a 60% accuracy there. There are issues though, so it's not all butter and bad bread and whatnot. So vectors are large. These numbers require space. We have seen that our database grown 7 times bigger, search became slower, and word fragments are not supported. So you have to put whole words in it so the AI can understand that. there are problems with acronyms and things like that. So that's the usual thing. But what we can do and how we can improve and use AI, there are multiple other places. And like, for example, duplicate detection. When you have a concept and you'd like to find the duplication of that, you can use the semantics built into SNOMED CT. But if, for example, one extension develops a concept and another, a different one, they use a different concept modeling, you won't be able to do that. You can try to find the similarity between the terms, but that's rely on the descriptions and how they were entered. AI can help with that. There are combined algorithms we can use. Even post coordination can be somehow baked into that. And I just realized that by visiting one of the sessions this week, and content validation can be improved. The decision support can be improved with AI. And one of the things with the mapping group, I realized that we have multi-language models. Excuse me. There are models out there that cover 100 languages in the world. You can produce vectors using these models to represent each of the concepts described in different languages and still have the same functionality. So you don't have to rely on keyword search anymore. You can use some kind of smartness that actually brings something to the table. And here at that point, I'd like to thank you, my team, the dedicated effort they have put into this large amount of work we have done in the last, I don't know, 1 year to make this happen. And the one good thing I think is you can try it. There's a link on the slide and you can go and try that. After this session, you should go and see if AI can improve your life or improve anything you use. Can be search or RefSet membership, RefSet authoring, or ontology alignment. Thank you.
Thank you, Mark. Thank you, Mark. We have time for some questions here in the room.
Hi, this is really interesting presentation. So you mentioned that word fragments are not supported. Are you talking about phrases that are not supported?
Not phrases, like just a stamped version or just some kind of prefix of a word. Like hematoma muscular, for example, if you just remove the you just reduce the word muscular to musk, it won't work. It understands the words a bit differently, and you need extra effort to be put into the AI model to understand that reduced word is actually relevant to the muscular.
I see. So it does support phrases.
Yeah, phrases, yeah.
Okay.
Yeah, sure.
And what about negation? How do you handle negation?
That's hard. Yeah, I think I read a forum post a week ago or two or something like that, and they said that it requires a huge amount of time to handle negation. It's easy to find something that's positively says that you are happy, but if the word says you are not happy, that not is actually hard. There are still issues, so it's not everything is bright. Yeah.
So Mark, is that also an issue for compound languages such as German and Swedish, where words get put together?
I hope so. We never tried that, but we would like to.
You were working solely in English?
I'm sorry?
Which languages were you working in? Just English?
You mean at my work or just...
Yes, in this.
But this is English only at the moment, but we are planning to put more research onto multi-language support. So eventually, with an improved AI model that supports multiple languages, you will have the capability of using it for not just English.
Thank you. Any other questions in the room? I have an online question. How much effort and knowledge is required to build this kind of search engine and/or integrate this feature with other services or solutions?
A lot. Yeah.
Someone had time to think about
a lot. Yeah, it's just I don't know, yeah, for the initial work, it was quite easy. It took like 2 weeks to produce something that works. But to produce something that actually works and have actual meaning or some kind of accuracy, that's just too much work. It's just, it consumes your soul and everything, because it's a lot. You need a lot of work, and you need a lot of knowledge as well, because it's not just the AI space. You need a deep understanding of SNOMED CT, a deep understanding of how languages English works and stuff like that. So it's a lot.
Okay, with that, we will conclude this session. Thank you, Mark.